Start
Okay,
recording,
maybe I go ahead and just start.
and I think we're good to go.
Okay, well I'll go ahead and start up then. All right, this is Hardware 301. I'm Glenn Berry, and my email's right there, glenn@sqlskills.com. And here's my Yay Me slide. The important thing here is my blog and also my Twitter handle. I'm pretty active on Twitter, which is a really good way to know people in the SQL Server community around the world. And here's a little bit about SQL Skills. We've got 6 people working for us. We do consulting and instructor-led training and online training through Pluralsight, so we're pretty active in the community also. All right, so before I get into the real presentation, I'm a home brewer. I make 19-liter batches of beer at home with an all-grain method, and that's my system that I use to make beer with. And then that's what some of my beer looks like, so that's one of my favorite hobbies. So anyways, the real presentation is we're going to talk about the importance of database hardware and the importance of processor selection for SQL Server 2017 and also for older versions. And we'll talk about some of the best Intel Xeon processors for SQL Server so you can get the best performance for the lowest license cost. And we'll talk a little bit about memory and some configuration issues for hardware. So that's what we're going to be talking about today. All right, so database hardware, database servers tend to be mission-critical assets that affect performance of multiple applications. And when there's a problem, people tend to notice really quickly. And if somebody did a really bad job when they picked out the hardware, it's pretty hard to compensate for that. And it's pretty common to have either not enough CPU capacity for your workload or not enough single-threaded CPU performance for your queries to be fast. And also, if you don't have enough memory, that's going to cause extra I/O pressure. I see that a lot out in the field. And then not having enough I/O performance and capacity can just cripple the system, and that's one of the most common bottlenecks that I see on busy systems. So doing a good job of picking your hardware can save so much on your license costs that your hardware is basically free. And you've got to actually do a good job and do some analysis and don't just let your system admin pick it with no input from you as the DBA. But it's really important to think about this because if you make a bad choice or just a good choice, you can spend a huge amount of money on SQL Server licenses that you didn't need to do. So SQL Server 2017 and hardware selection, nobody's ever come to me in my career and said that the database server is too fast. You know, they complain a lot when it's too slow, but it's never too fast. And if you're the DBA and you've got a really poor performing server and part of it's because of the hardware, you're the one that gets blamed for it and you have to deal with it on a daily basis. And brand new server hardware is very affordable compared to SQL Server licenses. And don't make the mistake of reusing old hardware from 3 or 4 years ago when you upgrade to a new version of SQL Server. That's false economy that's really going to do a disservice to you and your users. You need to be aware of the SQL Server hardware licensing limits, though, and make sure you understand going in, are you going to be stuck on SQL Server Standard Edition or you get to use Enterprise Edition? Because that has a big effect on what kind of hardware you might want to look at. And also, if you've got existing legacy hardware, don't be afraid to point out the age and the relative performance of your current hardware to your organization because they might not be aware that you're running on 3 or 4, 5-year-old hardware that's much, much slower than what's currently available. All right, so SQL Server 2017 licensing costs. You've got Standard Edition, which you can get with a server license, which is not very common. And then most people end up getting core licenses. And then you have Enterprise Edition, and the only way you can buy that is core licenses. So counting cores is really important when you're looking at hardware. And you can only have a minimum of 4 core licenses per physical processor. And the same way for virtual machines, you have to have a minimum of 4 unless you have enough licenses for the entire virtualization host and you have software assurance on top of that. Then you can make VMs any way you want to. But if you're not doing it that way, you have to have a minimum of 4. And if you do get a server license for standard edition, every person or every device that accesses the service has to have a client access license. So if you've got a very small number of users or devices that you can count easily, it might make more sense to get a server license with standard edition, but most people don't have that luxury, so they end up getting core licensing. And you can see that Enterprise Edition costs about 4 times as much as Standard Edition does. So that's why a lot of people don't get it, unfortunately. So 2017 has license limits. Enterprise Edition, you can use whatever the operating system lets you use. And with Windows Server 2016, that's up to 24 terabytes of memory. And on Windows Server 2012 R2, it's only 4 terabytes. And then you can use whatever the OS lets you use for numbers of sockets and numbers of physical cores. So there's basically no limits for Enterprise Edition. But Standard Edition, you're stuck with that 128 gigabytes of RAM for the database engine per instance. And you get a little bit of extra if you're using in-memory OLTP or column store indexes. So you can take that into account. But if you know you're going to be stuck with Standard Edition, you don't want to go out and buy a server with a terabyte of RAM because you won't be able to use but a small fraction of it per instance. Now, if you're willing to have multiple named instances, you might get away with doing that. But where this bites people more often is with the socket counts and with the core counts. So you're limited to the lesser of 4 sockets or 24 physical cores if you're not virtualized, or 24 virtual cores if you are virtualized. And I see this a lot of times with virtualization where somebody will create a VM with 8 sockets and 1 core per socket, for example, and Standard Edition only uses the first 4 sockets. So don't make that mistake when you're setting up your VMs. Make sure it's 4 sockets or less. And also make sure you don't go out and buy a machine with, say, 40 or 48 physical cores for Standard Edition, because Standard Edition will only use the first 24. And to make things even worse, it's going to actually not spread the cores evenly across both sockets. For example, it'll take all the cores on the first socket and any leftovers will go on the second socket. And you can fix that with an alter server configuration command, but out of the box, just the default install, you'll have an unbalanced situation. And these limits weren't changed at all compared to SQL Server 2016 SP1. So keep that in mind when you're looking at hardware. Now, CPU-Z is a free utility that's been around for quite a while. It came out of the hardware overclocking community, and it was a way to prove how far you could overclock your processor. But it's actually really useful for SQL Server to make sure you understand what kind of processor you have and how fast it's running, because you can have your processor throttle because of power management, whether it's at the BIOS level or the OS level or the hypervisor level. And this will help you understand what's going on with your processor speed. And there's also a quick little benchmark that you can run using this utility. So here's results of what it looks like on an AMD Threadripper. And this benchmark only takes about 10-15 seconds. And so it's safe to run, especially during a maintenance window, on a production database server to get a real quick and dirty feel for how fast your processor is. And the top part of it is the single-threaded performance, which is really important for OLTP query performance. And then the bottom part is the multi-threaded, which is your CPU capacity. And so you can use this to compare different machines and different processors to get an idea at a real high level of how their CPUs perform. So I actually have a demo of CPU-Z in case you've never seen it. And it's been around for a long time, but you fire it up and it comes up and takes a look at your hardware. And I've got an AMD Threadripper workstation. So here's what it looks like, the main screen. And you can see the current core speed right here. And it's actually a little bit faster than my base clock speed because I've got Turbo Core kicking in on an AMD processor to boost some of the cores up a little bit higher than the base clock speed. And then you can go in and see this benchmark right there. And if you click the benchmark CPU, it does a CPU multi-threaded test for a few seconds, and then it goes to a single-threaded test. And so again, this is a really easy way to compare. And this is also useful for virtual machines, by the way. So if you create a VM and you've got, say, 4 cores on that VM, you can run this and then create one with 6 cores or 8 cores and see how they compare. And you can also compare the single-threaded performance of your VM to the base virtualization host to make sure that virtualization is not misconfigured and causing you a big performance hit. So it's a really handy little utility that I use quite a bit. So going back to this, get into the meat of this, how large can you actually go on commodity hardware? Well, 8-socket servers are about the biggest you can get for commodity. So say Fujitsu sells an 8-socket server. And so if you wanted to get the very biggest physical server you could get in the commodity space, it would be at an 8-socket server. It would have 8 of the top-of-the-line Intel Xeon 8180M Platinum processors. And the bottom half of this slide goes into the cost components of this server. So Windows Server 2016, you have to license it by the core, but those licenses are quite inexpensive. So only about $12,000 for the Windows Server licenses. And then the Platinum processors, 8 of those would be about $104,000. And then RAM, unfortunately, has gone up over the last 12 to 18 months. So 12 terabytes of RAM, which is all this server can hold, is $184,000. But here's the killer, the licenses for this server. 224 core licenses would be almost $1.6 million. So everything else compared to the SQL Server licenses is much, much less expensive. And that's just something to keep in mind. It's going to be the same kind of a thing for any kind of a server you set up. So minimizing the number of cores that you have to buy licenses for is really important if cost is an issue for your organization. So this is the current Intel processor family tree. And this goes back to 2008. And so Nehalem was the first Intel server that supported NUMA. Before that, you had symmetrical multiprocessing. And so you had Nehalem, and then after that you have Westmere and Sandy Bridge and Ivy Bridge and Haswell and Broadwell. And where we're at right now is Skylake-SP that came out in the third quarter of 2017. And that's the latest and greatest Intel processor right now. And any current model server that you're going to buy is going to be using processors from that family. And then what's coming fairly soon, either later this quarter or the fourth quarter of 2018, is Cascade-Lake-SP, which is going to be a small evolution over Skylake-SP that will work in the same model servers. And so why this chart is useful is you can look at your current servers and kind of get an idea how old they are compared to the latest and greatest. So if you're running a Xeon E5 2600 series, you know, that's Sandy Bridge from 2012, and that's nearly 6 years old. And that's a way of kind of understanding how old it is and making the case to help convince your organization that it's time for a new server. So that's why this chart's useful. And then this is a little bit more information about the latest generation Intel server processor families. And if you're going to be running a very small single socket server, you can get the brand new Xeon E family servers that use the Coffee Lake architecture. And that just came out in the second quarter. And these are limited to 64 gigs of RAM, but they have extremely high single-threaded CPU performance. So if you had a very small workload that you wanted the very best performance on, that might make sense for you. But what most people end up doing is getting either 2-socket or 4-socket servers. And the Xeon Scalable family works in anywhere from 2 sockets up to 8 sockets. And it would actually work in higher if you had a 16-socket server. But what's important here is that they segregate this by different product levels. So you've got the Bronze family and then the Silver family, and you don't want those for SQL Server. They're the entry-level processors. And the thing you need to keep in mind is that Microsoft doesn't care if your processor is slow or fast. All they do is count the cores. So if you buy a slow 8-core processor compared to a fast 8-core processor, the license cost is exactly the same, and you're just giving up a lot of performance to save a tiny amount of money on the processor cost. So where you want to be for most people is the Gold 5000 series family or the Gold 6000 series family. And then the Platinum 8000 series family, that is better if you need really high core counts or you need to go above 4 sockets. But most people are going to be perfectly fine and better off, in fact, with the Gold family processors. But just make sure you avoid the Silver and Bronze family. That's a really bad choice for SQL Server. Now, this is a little bit a chart from Intel about some of the new features that are coming Cascade Lake. And there's not much information that's publicly available. Intel is really secretive lately. They used to be very good about talking about what's coming, but now they've been having problems with the 10 nanometer manufacturing process, and they've kind of gone secretive about new features. But what we are going to see is higher speed memory, and you're also going to see official support for the Apache Pass, which is special Optane DIMMs that fit in regular memory slots. So those are going to be supported by this processor. But outside of that, we don't know what's going to happen with clock speeds or core counts or anything else. That's the two main things we know about. And this is coming out very soon, probably in the next month or two. You'll see these. All right, and then another really good resource if you're looking at hardware from Intel is the Intel ARK Database. And all you have to do is type in the model number of a particular processor in your favorite search engine, and it's usually going to come up right at the top of the search results, a link to this ARK database. And then the ARK database will show you all the gory details about how many cores and how many threads and the base clock speed and the turbo clock speed and what features are supported. So instead of guessing, this gives you all the official information about that processor. All right, so this is another really good slide. And by the way, I sent the PDF slide of this to your user group leader, so you'll have that. But what these links go to is Intel has product briefs that are about 4, 5, 6 pages long on each one of these family of processors going back over the last 6 years that talk about, here's all the new features that came out for this family of processors. And so, for example, if you're a virtualization shop and you're looking for reasons why you should upgrade from an E5 2600 to the latest and greatest, you could go through each one of these and skim through it and find all the stuff that's related to virtualization. And believe me, they've made a lot of improvements in these generations of processors to make virtualization perform better and be more secure. So if you're a virtualization shop, that's what I'd be looking for. If you're not a virtualization shop, you could look for the performance improvements that they make, and they go into some detail and talk about them. So this helps you build the case for why you want a new processor and a new model server. All right, so I've got some charts here that show what I call the preferred processors at each core count. Because what you'll find if you look at that ARK database, you'll see that they typically have 3, 4, sometimes 5 or 6 processors at each core count level. And there's one among those 4, 5, or 6 processors that's the best for SQL Server. Because remember, the license is based on the core counts, not the performance. So if you want the highest core count processor because you've got a really big workload, then the Platinum 8180 is the best choice. And there's the specifications of it. Now the Platinum 8170, the one below it that I have in red, that's a really bad choice, unfortunately, because it has a really low base clock speed compared to the other ones. So that would be a terrible choice. You'd be much better off to get the Platinum 8168 with only 24 cores, but a much higher clock speed. And you would save a huge amount of money by having only 24 cores per socket to license instead of 26, and you'd actually have better performance and more capacity. So that's why looking at these charts and thinking about it is really important. That Gold 6154 that I have in green is a really good choice because it's got a very high base clock speed. And so that's the way you look at these charts. So this is for high core count, and then this next one is for low core count. So if you're looking at a smaller workload or you're really concerned about your license cost, you're going to be looking at this chart. And the one in red, the 6132 with 14 cores, that's a bad choice because of the low base clock speed. Where you want to be, for most people, is the gold 6146 would be a much better choice because it only has 12 cores, but it runs at a much higher clock speed. And you'll notice that the ones below that, the 8-core and the 6-core and the 4-core, they have very high base clock speed. So they're going to have very high single-threaded performance. And most OLTP queries are just running on a single processor core. They don't get parallelized. So your single-threaded CPU performance is really important, assuming you don't have bottlenecks on your storage or memory. Then your CPU is your final bottleneck. All right, so this is the previous generation Broadwell EP, the same chart. And you'll notice here that the one in red is a bad choice, and then the other ones are decent for high core count. And then here's the low core count for the same Broadwell family. And again, the one in red, the 10-core model, is a bad choice. And so don't get that. You want one of the other ones, either higher or lower, to maximize the amount of performance you get for your SQL Server license costs. All right, I've been talking about nothing but Intel, but AMD is actually a very good competitor now. They came out with their Zen architecture on the desktop, and then they came out with the same architecture in the server space, and it's called the EPYC 7000 series, and it came out in the second quarter of 2017, and it has up to 32 cores plus symmetrical multi-threading, so that means 64 threads, and it's got a very large L3 cache. But what's really important about this is it's got a huge number of PCIe lanes, 128 lanes per processor, and it also has very high memory density. You can have 2 terabytes of memory per processor. So you can build a single socket server that has a huge amount of memory and I/O capacity for a small data warehouse workload for a lot less money than you might be able to do with Intel with a 2-socket server. And you still have more lanes and more memory in the 1-socket AMD than the 2-socket Intel. And AMD is getting ready to come out with a 2nd generation EPYC that's going to shrink down to 7 nanometers. And it's either going to come later this year or early next year. So my point here is that AMD is a viable competitor to Intel in the server space. And that hasn't been the case for about 10 years. And this is really good news for us because this is going to push Intel to be more competitive, and it gives us 2 choices. We're not just stuck with Intel whether we like it or not. And so here's the preferred AMD processors, and they have fewer core count choices. So you can go 8, 16, 24, or 32. And these only work in either single socket servers or 2-socket servers. And many people who are used to buying 2-socket Intel servers can get a 1-socket AMD server and actually be better off, especially with a data warehouse or reporting workload. So, give AMD consideration here. And they have servers from Dell and HPE that use AMD processors now. So, all right, so how do you actually compare all these different processors that have been thrown around for SQL Server? Well, what I like to do is use the TPC-E OLTP benchmark. And what you do is you can go online to their website, and they list all the TPC-E submissions. And they're all for SQL Server, by the way. And what happens is whenever a new family processor comes out, the hardware vendors like HPE, for example, will submit a test that uses the flagship top-of-the-line processor with the most cores, because that's going to give them the highest overall score on the benchmark. But for us as DBAs, maybe we don't want that top-of-the-line 28-core processor. So what you can do is I'm going to show you how to go and do some calculations to figure out what a different model processor in that same family, how it would perform, because they're not going to do an official submission for that, unfortunately. So you go through and adjust the actual score to account for the lower core count and the different base clock speed that you might have on that particular one, and you can come up with an estimated TPC-E score. And so when you do that, Your total score is the CPU capacity of the system, which kind of tells you how many concurrent queries or how many users can I support. And then you take that total score and divide it by the number of cores in the system, and that gives you your single-threaded performance, which helps you understand how fast it's going to be for single-threaded queries. And once you have these numbers, they're really useful for doing some sizing calculations for upgrades or consolidation or virtualization. So instead of just guessing, you've got some numbers to do your estimates with. So I've got some examples of how you actually do this calculation, and you guys are going to get this document, by the way. So this is a Word document. It goes through, and these links go through to the ARK database and the TPC-E submission. So in this example, you've got a 2-socket server with 2 of the flagship Xeon E5 2699V4 processors. And there was an actual TPC-E submission for that that had a score of 4938. So that's the capacity of the system. So what we're going to do here is figure out what would be the score for a 2-socket server, that same server, with 2 of this processor, the 8-core processor, that more of us will probably end up buying. So I go through and show you the math here. 22 physical cores, here's the specs on that flagship. And then we go through and do the core count adjustment, 8 divided by 22, and then base clock speed adjustment. And we go through and take, here's the official real score times the core count adjustment times the clock speed adjustment, and here's the estimated score for the 8-core version of that. So then if you go through and do that math, here's the summary. Here's the official submission right here, and the score per core is 112.23, and the 8-core system has a lower capacity, which makes sense, but only 16 cores instead of 44, so the single thread performance is actually quite a bit higher. So you can go and do this for every single one in the family if you want to, and I've actually done that. And so I'm not going to give you the full spreadsheet, but you get one page of it right here. So this shows all the processors in that entire family, and it shows you all the specs here. And then here's the scores, and the one that's hyperlinked is the official one. And all these other ones are the estimated ones using this methodology. And so this gives you a quick and dirty way of doing the capacity and then the performance of any processor in this family. And if you do this for each single family, then you can compare across families. And you can use that to compare a legacy server to the server you're thinking about buying to make sure you're going to have enough capacity for the upgrade or to do a consolidation or virtualization effort. So that's how that works. And again, you're going to get this single page spreadsheet and that Word document that shows you what I was talking about. So going back to the PowerPoint, this is an even more valuable slide because I do, okay, here's the very best processors at each core count and their numbers. So that Platinum 8180 that has 28 cores, here's its estimated capacity, and then there's 56 cores you have to get licenses for in a 2-socket system. And then here's the score per core, so that's how fast it's going to be for single-threaded. But then here's how much the license would cost for that system. You know, $400,000 for a 2-socket server for the SQL Server licenses. And again, you can see that this gold 6154 does really well. And here's another example, the Platinum 8170, here's its capacity compared to the 8168. It actually has more capacity. And then you're having fewer cores to license and better single-threaded performance, and you're saving $28,000 in your license costs by picking this processor instead of this one. And the entire server will probably cost less than $28,000. So just by picking this one instead of this one, you're saving so much money that the server is free and you're getting more capacity and better performance at the same time. All right, so here's the same chart for the low core count Skylake-SPs. And again, this is for a 2-socket system, which is what most people buy. And so, again, the 6132 is a terrible choice. And you'd be much better off with the 6146. It's got more capacity and better performance, and you're saving $28,000 on your license costs by picking this one instead of the one above it. And then the ones in green, most people, in my experience, are perfectly fine with these three, depending on the magnitude of your workload. And they're the ones that are super fast, because that's what happens with lower core counts. You've got more thermal capacity to boost the clock speed, and that's what Intel does, and they run them faster. So that's for Skylake-SP low core count. And then here's the same thing for Broadwell EP, high core count. And you can see the numbers here. And the ones you want to avoid, are the ones in red. So, for example, this is a terrible choice compared to the one below it. The capacity is about the same, but the performance is different and the license costs are different. And then here's the same thing for the low core count Broadwell EP. And again, the ones in green are really good choices. The one in red is a bad choice. And again, keep in mind that these are the best choices at each given core count, because they have several SKUs at each core count, but these are the best ones at that core count. All right, so here's an extreme example to finally drive this point home, I hope, of really bad CPU choice versus a really good CPU choice. So imagine you're getting ready to buy a brand new 2-socket server, and what you could do if you didn't know any better, if your server admin just went out and he's trying to save some money on the hardware. So he goes and picks the Xeon E5 2609 V4, because it's a very inexpensive processor, and he gets 2 of those, and it's an 8-core processor, and it doesn't have hyper-threading, and it doesn't have turbo boost, and it runs at a very low clock speed, so it's very slow, but it's very inexpensive. And then the good choice would be 2 of this processor, the 2637 V4, that only has 4 cores, but it has hyper-threading and turbo boost, and it runs at very high clock speed. So the good choice would have this much capacity, more than double the bad choice, only 8 cores to license, and then the performance would be 4 times better, more than 4 times better, and then the license cost, you'd save $57,000 on your license to have double the capacity and 4 times the performance. So that's a very extreme example of a terrible choice an unknowing but well-meaning server admin might make compared to a very good choice in the same exact server. So processor choice is really, really important for SQL Server. All right, so moving on, I'm going to talk about something called a modern data retrieval hierarchy. And in a database server, you've got your processors that have a level 1 cache, and a level 2 cache, and a level 3 cache. And you can see here the top 3 lines, each cache is much faster. So level 1 cache is a lot faster than the level 2 or the level 3, but it's much smaller. And so if you're really lucky, when you're running a query, you find the data you want in the L1 cache. But that's not going to happen that often because it's only 64 kilobytes per core. But maybe you get a little bit less lucky and you find it in the level 2 cache, but then the latency doubles, and so on. So you go to the level 3 cache, which is much larger, but it's shared across all your cores, and your latency doubles once again. So that's been around for quite a while, that hierarchy within the processor. But if you don't find what you're looking for on the processor itself, you've got to go out to main memory. And main memory is a lot slower than the caches on the processor, but it's still a lot faster than anything below it. And then back in the old days, if you didn't find it in the SQL Server buffer pool in main memory, you had to go out to storage. And back in the really old days, that would be magnetic storage at the very bottom of this chart. But what we've gotten since then are additional layers in between the memory and the magnetic storage. And so, people like to say, well, I've got flash storage. I've got all flash storage. But keep in mind that not all flash storage is the same. You've got lots of different kinds of flash storage. So the first kind of flash storage that became available, and the kind that a lot of people are still using, is SAS or SATA flash storage using the old AHCI protocol that was designed for hard drives. And that's a lot faster than magnetic drives, but it's still not nearly as fast as some of the newer kinds of flash storage. So that's the second one right here. But then what a lot of people are moving to is PCIe-based NVMe protocol flash storage. And it's a lot faster and has much higher bandwidth than SAS or SATA. And this protocol, NVMe, compared to AHCI, puts less stress on the host and it's more efficient. So it's much, much better. So that's where a lot of people are running now for things like TempDB or log files, transaction log files. But something you might not have heard of is Intel has a fairly new technology called 3D XPoint, and their marketing name for it is Optane. So Intel has something called the Intel Optane DC P4800X, and this can be either a PCIe add-in card or a U2 2.5-inch drive that fits in a server. And these things don't use NAND storage. They use what's considered to be phase change memory. And it has much, much lower latency than NAND storage does. And it performs much better at lower queue depths for random I/O performance. So this works really good for TempDB. If you've got a really heavy TempDB workload, maybe you're using RCSI, for example, and you're putting a lot of stress on TempDB, switching your TempDB to these cards can make a huge amount of difference. I've had several clients in the last several months switch from NAND flash storage to this and see a huge performance improvement. So that's been around for about a year now. But what's even newer is persistent memory. And persistent memory is memory that's backed up by a capacitor or battery so it doesn't lose the data when the server's turned off. And there's two different kinds of that persistent memory. One that's been around for about a year that uses the capacitor or the battery, and then Intel is getting it ready to introduce Intel Optane DIMMs that also are persistent. And so you can use block mode or direct access mode here. And so the point of all this is that you've got additional layers between the memory, the physical memory, and the storage that you can take advantage of for TempDB, or for SQL Server 2016 and newer, you can do something called the persisted log buffers feature that I'll talk about in a minute here. So that's this slide. This is a new feature they added in 2016 Service Pack 1, and it uses those non-volatile DIMM persistent memory chips. And what you do is you put those in your server, and then you go in through Windows Server 2016 and create a volume so it looks like a drive letter. And it has to be set up to be on a DAX volume, direct access volume. And so you create this little small drive that uses that persistent memory, and then you go and create a little second 20 megabyte transaction log file for your database. And because normally having more than one transaction log file doesn't help you performance-wise, but this is an exception to that rule. So if you've got a workload and you're seeing lots of write log waits because you're inserting or updating, many thousands of rows per second, and you're seeing write log waits, using this can help get around that because it caches the tail of the transaction log on this incredibly fast storage that's persistent memory. And it's pretty cool if you've got that kind of a workload. It works really well. Now, it does have some limitations in 2016 and 2017. It doesn't work with transparent database encryption, and it doesn't work with availability groups on the primary side. It does work on an AG secondary, though, and it doesn't work with virtualization unless you're using Hyper-V on Windows Server 1709 or later. It does work on VMware 6.7, though, so if you've upgraded to the latest version of VMware, you can take advantage of this with virtualization. So that's what an NVDIMM looks like, by the way. And it just fits in a regular memory slot on your server. All right, general memory considerations. As I talked about in that hierarchy, physical DRAM is faster than any of the other lower storage layers. It's give you much lower latency and much higher throughput. So don't skimp on your memory. I see this all the time where somebody goes out and buys a brand new server with the right processor, and then they put 16 gigs of RAM in it. You know, I've got 64 gigs of RAM on my desktop and 32 gigs in my laptop. And if you're under memory pressure in a server and you're not giving it enough memory, that's just a terrible mistake that's easy to fix, although unfortunately memory is more expensive than it was a couple of years ago. And hopefully over the next year or so, memory prices are going to go back down again. But anyways, having a large SQL Server buffer pool reduces the number of physical reads you have to make because you're finding most of the data you need in the buffer pool. You're doing logical reads instead of physical reads. And also, it helps reduce how often you're having to do lazy writes and checkpoints, which helps even out the write workload to your data files. And the feasible goal that you can easily do in many cases is have your entire active workload fitting in the buffer pool. Because remember, you can have up to 24 terabytes of RAM with Windows Server 2016. But unfortunately, RAM is kind of expensive compared to a couple of years ago. But still, compared to SQL Server licenses, RAM is inexpensive. So, other things about memory. On Broadwell processors and older, this is really important. It's not as important on Skylake and newer, but on Broadwell and older, only having one DIMM per channel gives you the very best memory performance. And you're going to get the highest bandwidth. And so if you had a 2-socket Broadwell server, that means 8 DIMMs instead of 24. If you need to fill all of them because you've got a really big workload, go ahead and do that. You know, because even slower memory, because of all the DIMMs being populated, is going to be faster than your storage. But if you have a fairly small workload and you can get away with only having 1/3 of your DIMM slots populated, you're going to get better memory performance if you do that. So all the server vendors like Dell and HPE have memory configuration utilities you can use to make sure that you're getting the right kind of memory and you have it in the right slots and you're using the right BIOS configuration to get the best memory performance. And this is really important for SQL Server that you get this right, that somebody pays attention to this and checks that it's right. So other hardware configuration tips that I see being skipped a lot, because what I see happening in the field a lot is you've got server admins who don't know much about SQL Server, and you have SQL Server admins who don't know much about hardware or storage. So some of this kind of stuff kind of gets skipped. So it's really important when you first get a new server, or if you've got existing servers that you don't know that they were set up properly, that you go into the BIOS and make sure that everything's set up correctly. So you want to make sure all your BIOS settings are correct, and you've got the latest version of the BIOS and any other firmware or drivers, and make sure that all your device drivers are the latest versions. And also, it's super important, especially with NVMe storage drives like from Intel and Samsung, that you use the vendor-specific driver instead of the one that Windows will install automatically. So if you go out and get one of those Intel Optane storage drives that I was talking about earlier and just throw it in your Windows 2016 machine, Windows will automatically use a generic Microsoft NVMe driver, and you don't want to do that. You want to make sure to install the Intel NVMe driver. You'll get better performance if you do that. It's another thing that's really important, especially for those kind of drives, is make sure it's in the right PCIe slot, because different slots have different numbers of lanes. So you'll see like an X4 slot or an X8 slot, and you want to make sure it's in a fast slot so you're not artificially restricting performance of that device. And then it's also, again, important to make sure that your memory DIMMs are in the right slots and you've got them configured correctly. And these utility programs like CPU-Z and HWInfo64 can be used to make sure that everything's set up correctly in the BIOS. So here's some examples of some BIOS settings that you want to think about. Intel Turbo Boost or AMD Turbo Core, what that does is it boosts the clock speed from the base to a higher speed, and you always want to have that turned on. There's absolutely no reason not to have that enabled. but maybe some misinformed server admin went in and disabled this in the BIOS, so make sure it's enabled. Hyperthreading, that should be enabled in probably 99% of the situations. It gives you about 25 to 30% more capacity for OLTP workloads. You can run a few more queries. It doesn't double it like you might think. And it can hurt your performance in some data warehouse workloads, but that's pretty rare. And I wouldn't disable it unless I benchmarked it both ways. And processor power management is also really important. Make sure that it's either set to OS control in the BIOS or just disabled completely. And your BIOS level power management is going to override the Windows power plan, and it's also going to override what you ask for in the hypervisor if you're using virtualization. And again, you can use that CPU-Z utility to make sure that it's not being throttled back by power management. And also, it's really important if you are using virtualization that the hardware virtualization features are enabled in the BIOS. So you get VTX and VTD support for Intel processors, for example. If you don't have those turned on, that can have a very significant effect on your virtualization performance. All right, so power management. I've talked about this a little bit, but this has a very significant negative effect on performance. It's great for laptops. It gives you much better battery life, for example, and it helps reduce your electrical bill. But for a mission-critical database server, power management is very, very bad. And I've seen it in the 20 to 25% range, having power management instead of not having it, depending on your workload. And so there's 3 levels of power management. You've got the hardware level from the BIOS, then the hypervisor level if you are running a hypervisor, and then the Windows power plan. And the hardware overrides the hypervisor, and the hypervisor overrides the guest OS power plan. And what happens with power management is it throttles back the clock speed of your processor to reduce your electrical usage. And then when it sees an increase in the workload, it tries to throttle it back up to full speed and to turbo speed. But the problem is it takes anywhere from 100 to 150 milliseconds to throttle up, depending on the family of processor. And the problem is a lot of OLTP queries are done in less than 100 or 150 milliseconds. So your database server is sitting there relatively idle, and then a query comes in and hits it, and it tries to throttle up, but the query is done before the throttle process even occurs. So your query is slower because of that. Now, Intel has a feature on the latest Skylake processors called speed shift. It's different from speed step that you might have heard of. But if you've got speed shift and it's enabled in the BIOS and you're running Windows Server 2016 or Windows 10, then it reduces the speed that takes a throttle up to only 20 to 30 milliseconds. So that reduces the hit you take from power management. But again, for the mission-critical database server, just don't have power management enabled at all, and you want to deal with this problem. All right, here's what the power plan settings look like, and make sure if you don't do anything else, that you go and check all your servers and make sure they're not in the balanced power plan, switch them to the high-performance power plan, and that takes effect immediately. No reboot or no restart of SQL Server is required to get that benefit. So just to review some of this stuff, processor selection is just critically important for SQL Server because it drives almost all your other hardware and storage choices. The memory controller is on the processor. What level of PCIe support you get is on the processor. How much memory you can have and how many cores and how many sockets is controlled by the processor. Now, modern Intel processors are usually the best choice for SQL Server because they have the very best single-threaded performance, but these new AMD EPYC processors can be a really good choice, especially for data warehouse and reporting workloads. And when the second generation of those comes out early next year or late this year, give those a hard look because they may actually be just as fast as the Intel for single-threaded performance. And then think about your workload as you're choosing your hardware. Is it more of an OLTP workload or more of a data warehouse reporting workload? So that's going to affect what processor you pick and how much memory you get, and what kind of storage you get and how you configure it. It's all really important to think about. And then also make sure you think about, am I going to be on standard edition or am I going to be on enterprise edition? because that's going to affect your hardware choices because of those license limits that Standard Edition has. So I've got some references here. I've written a whole bunch of blog posts and articles about processor selection for SQL Server. And then here's a link to the ARK database for Xeon processors. And there's a link to the AMD EPYC server processors. And then there's a really good blog out there called Serve the Home that does lots and lots of benchmarks of servers and processors and storage. And it's very IT oriented. So I suggest you subscribe to that blog and read it. And then some more references. I've got a couple of Pluralsight courses on scaling SQL Server, on how to improve performance. And then Microsoft has a couple of free programs that you can join. One's called Visual Studio Dev Essentials and one's called Azure Essentials. And if you join them, you get all sorts of free stuff from Microsoft. So you might as well take advantage of that if you're working with Microsoft and SQL Server. So then we've got the SQL Intersection Conference coming in Las Vegas in a few months. So that's pretty much it. I've got time for questions if you guys have any. And if you have questions you think of later, you can send me an email, Glenn@SQLskills.com.
Thank you, Glenn. Any questions? Anyone? מיכאל. רוצה לבוא, להגיד לי ואני אתרגם, איך אתה רוצה? בוא לפה, נראה לי יותר... Yeah, we have a question. 1 second. Can you hear me, Glenn?
Yes, I hear you.
Okay.
You hear me?
Yes, I can.
You said that we should always turn on the turbo mode for CPU, but when you spoke about cores, you always put in bold the base clock speed. Should we look at base clock speed or the turbo?
Okay, well, I think I understood your question. I said you should always enable turbo boost or turbo core, but then when you're comparing processors, you should look at the base clock speed because your processor is going to be running at the base clock speed most of the time. If it's kind of lightly loaded, not much of a workload, then you're going to see some of the cores go up to turbo momentarily, but they're not going to run at turbo full speed all the time. So you want to look at the base clock speed when you're comparing performance because that's what you're going to be actually running at most of the time. And if you're lucky, you'll occasionally see it go up to turbo for a little bit, but it won't run there very long. So that's why you look at the base clock speed when you're comparing processors.
All right, thanks. Any other questions? Anyone? Yeah. Can you go back to the slide about the BIOS?
Sure. Is that the one you wanted? And hopefully nobody's scribbling notes or taking pictures because you're going to get the deck.
Yeah.
So
the question is, are these the default values?
yeah, well, in most BIOS, the turbo boost is enabled by default. But sometimes I've seen server admins turn them off because they think it's going to make the processor overheat, which is not the case. If the processor starts to overheat, it'll throttle back automatically, so there's no danger there. And then hyperthreading is usually enabled by default, but then if you go and look on the internet, you'll find old blog posts that say that hyperthreading is bad. And it used to be kind of bad 15 years ago when the very first generation of Intel processors that used it came out, but the modern Intel processors work very well with hyperthreading. So that's why somebody might have disabled it, even though it's going to probably be turned on by default.
It says there it can hurt performance for some data warehouse workloads. How come? Why is that?
Well, because if you've got a query that's parallelized across many, many processor cores, then you're going to get CX packet weights, and sometimes that can slow down certain queries when hyperthreading is turned on. But it's not very common. It depends on the query. And I wouldn't let this scare you. Oh, I've got a data warehouse workload, so I'm just going to turn off hyperthreading. Test it both ways. if you're worried about it. And most of the time, you'll be better off with it turned on, but there's a few exceptions where sometimes it does hurt query performance, but it's only going to be for certain queries.
Okay. I think that's it. All right. Thank you very much, man.
How many people are there?
20, 25, maybe?
20, 25? Okay. Because Paul always wants to know, so I just needed to ask that.
All right.
All right. So
Thank you.
Thanks a lot for letting me speak.
Thanks.
All right. Well, I'm going to go ahead and jump out, and you guys can do the rest of your meeting.
All right. Thank you. I'll stop the recording now.
All right.